Let's talk about relations and functions. A relation is a relationship between two variables. Let's say we have x and y, or two sets, set x and set y, such that each value of the first variable is paired with one or more values of the second variable. So let's say we have some values in x here. We have 0, we have 1, we have 4. Then we have, let's say, -1 here. We have 0, we have 1, we have 2. Now, we can map this to this. We can map this to this as well. We can map this again to this. Then we can map this to this. So this is what we call a relation. So when we have a relation, then we have a domain, we have a range. The domain refers to the set of all possible values of this first set x. So domain will be all the set of possible values of x. So 0, we have 1, then we have 4. That's the domain. Then when we talk about the range is a set of all possible values of the second variable. So the range will be -1, 0, 1, 2. Now when we talk about the codomain, let's say we have another value here, say 3. This time we don't have anything mapping onto that 3 in a second set. So the codomain will be -1, 0, 1, 2, and 3. So you can see that the range is a subset of the codomain. Now let's talk about functions. If the relation is such that each element in the first set maps onto exactly one element in the second set, then the relation is a function. So this is a relation, but it's not a function. However, these relations here are functions. This relation is also a function. We can see that each element maps onto exactly one element in the second set. Each element in the first set maps onto exactly one element in the second set. Let us now talk about function notation. An equation can represent a function. For instance, the equation y is equal to 2x plus 1 represents a function. We can express this equation as a function using function notation. So we are going to rewrite this equation as f of x is equal to 2x plus 1. So the function notation for y equal to x plus 1 is f of x equal to x plus 1. So if this is x, the values here represent x, and the values here will represent f of x. So x will map onto f of x. So the f of x is 2x plus 1. So if you have a value here, let's say -1, then that value will map onto So f of -1 will be equal to 2 times -1 plus 1. And this will give you -2 plus 1, which is equal to -1. So -1 will go here. -1 will map onto -1. And let's say we have 0 here. So 0 will map onto f of 0. And f of 0 will be equal to 2 times of 0 plus 1. This will give you 0 plus 1, which is equal to 1. So 0 map onto 1. Let's say we have 50. So 50 will map onto f of 50, which is equal to 2 times of 50 plus 1, which is 100 plus 1. And 100 plus 1 is 101. So you can now write a function as a fraction notation and evaluate it. So if I give you y equal x squared plus 1 and I ask you to write it as a function notation, then you get f of x is equal to x squared plus 1. And if I ask you to evaluate f of x at x equal -2, then that will be f of -2 is equal to -2 all squared plus 1. And that will give me 4 plus 1, which is 5. Sometimes the function may be given in a mapping form. F is such that x maps onto, let's say, 1 over x plus 3. So you can write it in a function notation as f of x is equal to 1 over x plus 3. It is now your turn to try these questions. Evaluate f of x equal 2x cubed plus 3x minus 10 at x equal 2. Then given that g is such that x maps onto 1 over x, where x is not equal to 0, find the value of g at 1 over 2. Try them. You can find the answers to these questions in the video entitled Solution to Trial Questions in this playlist. Thank you very much. Now let's move on to kinds of functions in the next video.